Imagine waking up tomorrow and seeing robots that move, think, and react like humans. Not in some sci-fi movie, this is happening right now. Humanoid robots are evolving at an insane speed, and the latest breakthroughs are nothing short of terrifying. From robots that can actually feel objects to AI-powered machines that roast humans in conversations.
I'm not a big fan of your sense of humor.
The recent avalanche of breakthroughs suggests we're speeding toward a world most of us never imagined we'd witness so soon. But here's the real question. Are we actually ready for it? From advanced tactile sensors that give robots a sense of touch almost as refined as a human's, to entire bipedal machines gearing up for off-world colonization, the stories emerging today promise both wild opportunities and serious controversies. Instead of relying on old clichés about robots taking over, we're going to cut to the core of what's happening in real labs, major tech expos, and R&D centers. By the end of this journey, you'll have a clearer picture of just how fast these creations are evolving, and why some people are worried they might shift the balance of power in ways we can't predict. So buckle up. This is a tale of innovation, ambition, and a dash of unease as the line between science fiction and reality starts to blur. The Electric Leap, Boston Dynamics, and the Atlas Update. If Sanctuary AI has focused on refined motor skills, Boston Dynamics has long made headlines with jaw-dropping videos of robots dancing, jumping, and navigating obstacle courses. Their iconic bipedal creation, Atlas, once relied on hydraulics for many of its agile stunts. Hydraulics offered raw power and rigidity, letting Atlas perform backflips and sprints that made it look almost superhuman. But the latest chapter in Atlas's evolution involves a transition to a fully electric system. And with that shift comes a fresh wave of awe and anxiety. In a recent behind-the-scenes reveal, Boston Dynamics engineers discussed how complicated it is to replicate hydraulics' natural stiffness using electric motors and advanced control algorithms. When Atlas picks up a heavy box, the force distribution can change in an instant. The robot's spine has to adjust to keep balance. If one joint is a fraction of a second late in responding, the entire system could topple like a tower of blocks. That's where Boston Dynamics' expanded use of AI-driven training data comes into play. Each time Atlas lifts, walks, or sets something down, the onboard software logs every force, angle, and success or failure. Over time, the robot's capacity to handle shifting loads with grace inches closer to that of a skilled warehouse worker. It's not just about parlor tricks anymore. Boston Dynamics wants Atlas to function in real-world conditions, such as car assembly lines or large-scale warehouse operations. Imagine a future where you walk into a manufacturing plant and see these upright machines calmly organizing parts, performing precision tasks, and maybe even checking in with each other to coordinate. The company has played down talk of replacing humans, emphasizing that these robots excel at tasks that are repetitive or dangerous. Yet the line between collaborative helper and cheap labor alternative is already a hot debate topic. Another concern is how rapidly Boston Dynamics could adapt Atlas for different scenarios, including the potential for militarized uses. While the company has often stated a desire to steer clear of weaponization, critics question whether that stance can hold firm if major governments and defense contractors come knocking with lucrative offers. Already, some observers see parallels between advanced drones used by the military and these new bipedal robots that can navigate rough terrain. For now, the big take-home is that all-electric, AI-guided robotics are forging ahead, and Boston Dynamics Atlas is a prime example of how quickly performance can accelerate once you crack the code on balancing, coordinating, and controlling complex motions. But the next big jump might not just be physical. It could be how robots decide their tasks. And that's a step that many watchers find both exhilarating and deeply unsettling. The new touch, Sanctuary AI's tactile revolution. Over the past few years, certain robotics companies have moved beyond teaching machines to simply walk or stand upright. They're diving into that trickier realm of dexterity, the fine motor skills we humans take for granted when we peel an orange or fasten a tiny screw. One of the major pioneers here is Sanctuary AI, a name that keeps cropping up among experts who claim it's reshaping what humanoid robots can feel. The buzz revolves around a set of newly integrated tactile sensors that turn mechanical fingers into sensitive instruments. Imagine a metal hand that can sense the exact moment it brushes against a delicate wire, the subtle difference between gripping a half-full glass and a heavy wrench, and the gentle push needed to rotate a small knob. Until recently, most robots relied solely on cameras. Their only feedback was visual, like a person trying to tie shoelaces with thick gloves, guided only by looking from a distance. But Sanctuary's approach changes all that. Behind the scenes, These tactile sensors measure minute levels of pressure, close to the sensitivity of an actual human fingertip, thanks to barometer-like technologies that detect even 5/millionths of a certain pressure unit. That's only slightly above human skin's threshold, meaning the robot can swiftly realize if it's about to break something fragile or if an object is slipping from its grip. This advancement isn't just about fancy research labs. It's the foundation for letting robots handle tasks that require nuanced force, picking up eggs without cracking them, assembling tiny electronics, or even dressing someone who needs assistance. The deeper implication, which stokes both wonder and fear, is that more sophisticated touch leads to more data. Every time a sanctuary AI robot grasps a tool or interacts with a surface, it sends real-time info back to a central system that's constantly learning. In theory, the more the robot touches, the more it refines its approach. Over months or years, that knowledge bank becomes enormous. Some insiders speculate this might eventually allow robots to outperform humans in highly specialized tasks. Others worry about the possibility of entire industries shifting toward machines able to do everything from manufacturing to surgery. But that's only the beginning. Once a humanoid robot becomes confident with the sense of touch, the leap toward full autonomy feels inevitable. Already, companies like Sanctuary AI are describing a future where the standard assembly line job might be done faster and with fewer mistakes by a tireless mechanical workforce. In response, critics raise concerns about the social and economic ripple effects. Are we prepared to handle massive job displacement? Will regulations be strong enough to ensure these robots remain tools rather than overlords? For now, Sanctuary AI insists it's about collaboration and augmenting human capabilities, not outright replacement. Yet that's small comfort if you're picturing a near-future workplace stacked with metal arms quietly doing everything. Beyond Earth, Mux Robotics and off-world innovation. While some humanoid robots spark chatter over job losses, others are being built with a far loftier goal: space exploration. Enter Mux Robotics, an Indian firm stepping into the limelight by crafting humanoid models designed for the Moon and Mars. Their prototypes, named SPO Prime and Robo Prime, promise to tackle the kind of rugged landscapes no standard rover could handle with grace. SPO Prime, a bipedal humanoid, is intended to walk around on alien terrain, collecting samples and performing tasks that might be too dangerous or too delicate for untrained astronauts. Meanwhile, Robo Prime, with a specialized frame, can roll or crawl through treacherous rocks and craters. The aim is to establish a fleet of robotic helpers that can set up and maintain off-world habitats before humans even arrive. That means building structures, running power lines, and performing initial repairs in the event of dust storms or radiation blasts. Some envision a near future where cargo ships land on Mars, offloading dozens or hundreds of these bipedal workers, who immediately get to constructing a livable base. No need to risk human lives in that first wave. Let the machines do the heavy lifting. Over time, they'd gain enough autonomy to adapt to new challenges, like unexpected rock formations or equipment malfunctions, sending data back to Earth in near real time. For space agencies flirting with the idea of permanent settlements on Mars, this level of robotic assistance might be a game changer. But not everyone is convinced. Critics argue that the complexities of planetary environments, radiation, dust, storms, extremely low temperatures can wreak havoc on delicate electronics. Mux Robotics, however, claims they're already factoring this in by using specialized materials and advanced AI designed to self-correct when sensors get compromised. There's also an ethical conversation brewing. If these robots become advanced enough to make decisions independently, how do we ensure they don't inadvertently sabotage missions? If we're not on the planet to oversee them, do we risk unexpected outcomes that could set back an entire colony plan? Despite the uncertainties, Mux Robotics represents a bold step into a domain that once felt purely speculative. Whether they succeed or not, they're throwing down a challenge to the rest of the industry. If you can build a robot that thrives on Mars, what else is possible back here on Earth? The dawn of a new era. Behind the dazzling demos and press releases, a swirl of rumors, controversies, and whispered predictions is painting an even more dramatic picture. Some corners of the internet are rife with talk about a near-future robotic arms race, where nations and corporations compete ferociously to build the most advanced humanoids, sometimes with questionable intentions. Could a next-generation humanoid be outfitted with advanced weaponry or used as a remote soldier that feels no fear or hesitation? Others raise alarms about workforce upheaval on a scale we've never seen. If you combine lifelike dexterity, advanced AI decision-making, and cost-saving hardware strategies, you could theoretically place a humanoid in countless roles currently occupied by humans. from factory lines and trucking to construction and retail. This scenario stokes new calls for universal basic income or more robust social safety nets, as well as lawsuits from labor unions that might fight to protect their members' livelihoods. In the midst of these serious considerations, there's excitement too. Excitement that we're on the brink of transformations as monumental as the Industrial Revolution or the dawn of the Internet era. Some say advanced robotics will free us to pursue creative, intellectual, or communal pursuits, while machines handle the drudgery. Others argue we'll simply end up with a new social order where the wealthy keep robots, and the rest are left scrambling to stay relevant. So will tomorrow's world be a place where humans and humanoids collaborate seamlessly, each playing to their strengths? Or will we see entire sectors dominated by cold, metallic workers that can operate around the clock without needing breaks, paychecks, or compassion? The only real mystery left is how prepared we'll be when these humanoid creations step out of tech expos and laboratory confines and into the heart of our cities, our workplaces, and maybe even our homes. Finally, the big question is, which version of the future will we choose? Right now, it's a race between unbridled progress and thoughtful oversight. Now, take a deep breath and see you next time.